Thank you, Ertemann, for coming on to the podcast with us. Ertemann is the Secret Network Education Lead and Technical Writer, and also hosts his own podcast, Agents of the Round Table, weekly on Spotify. Is there any other socials that's on Ertemann?
I think you can best find me on Twitter, but the podcast is you can find it on YouTube, Spotify, any podcast platform basically.
Nice. All right, so I know that you're well versed in the crypto space, and we're excited to get into discussions of multiple platforms. But could we just chat quickly about Secret Network and maybe a bit of background on the project as well?
Yeah, of course. So what I do is I do education, like user education, and also developer help for Secret Network. I write some technical content. And Secret Network is a blockchain within the Cosmos ecosystem. So it uses the Cosmos SDK and the Tendermint consensus mechanism to provide people with privacy preserving smart contracts. So smart contracts on Ethereum, for example, they have no option for private metadata. So if you do something, then everything is public. Everyone can see your collateralization ratio, which NFTs you mint, and basically everything beyond that. But on Secret, it uses novel encryption mechanisms to basically encrypt all your information you're putting into the smart contract on the user side. And then all the validators use a specific technology called trusted execution environments, um, which holds this private information and can process over this private information without revealing the info to the validators. So the validators don't have any access to the data, meaning the blockchain is both private but also front-running resistant because the validators can't change the ordering of the transaction. So this just enables a lot of novel applications and use cases which you can't have on other blockchains, like on-chain identity or user-side encryption for communication or encrypted file storage or private lending
Hmm.
or collateralized lending and so forth. So that's what Secret does, and it's IBC enabled, so it has its place within the Cosmos ecosystem where it provides privacy to other blockchains. So, for example, Osmosis or Juno, which are other blockchains in this ecosystem, they can request a contract on Secret to do something for them. So they can have like private voting by leveraging Secret or get a random number from an on-chain mechanism instead of an oracle. More interesting use cases like this. So Secret is sort of the privacy hub for the entire Cosmos ecosystem.
Oh, that's really cool. So it can pretty much be for the entire Cosmos ecosystem. Does that also translate over to because it has IBC? Does that also go to like crypto.com as well? Because I know crypto.com's connected to Cosmos in a big way.
Yeah, CRO is also IBC enabled, but they don't have IBC smart contracts yet. They only have value transfer, like only tokens. So the only other two chains currently which have smart contracts available as well over IBC are Juno and Osmosis.
Interesting. This might be a good time to get into how you found Secret Network and how you got involved with them. So maybe you can elaborate a little bit on that for us, Erdeman.
Yeah, of course. I think it's more than 1.5 year ago currently. So I actually started my crypto journey in February 2020. Yeah, February 2020. Um, I must say, sorry, February 2021. I'm missing a year. Anyway, so almost at like the exact top of the last bull market is when I got in. I got interested, and of course got started with all the things that were hype back then, like Cardano and Chainlink and whatever. But I always found the slogan of Cosmos very interesting, like the internet of blockchains. So I dove a bit deeper, and I think there was like a small period where there was not a lot going on, and then I dove deeper into some Cosmos protocols, and I found this Hashoshi podcast by like this podcast by Hashoshi about Secret Network. It had Tor Bear, which is a one of the network leaders. Basically, he hosts the foundation, the Secret Foundation, and then after that, I just dove in. I realized why privacy is so important. I've always been an ethos-driven person. So privacy is, it's something I deeply care about. And after that, I just got in further and further, joined the agents program, did a lot of community support because a lot of people were using bridges and dexes and having some trouble. So I was helping people in the Discord, and then I got invited to join the support team. And after that, it sort of moved into to a bigger and bigger role. So I worked for the community pool for a bit, and recently we have moved some things from the community pool off to a separate organization, which is called the agency, and that's where I do my work for Secret Network currently.
Yeah, awesome. Yeah, same for us is February 2021. It's when we
Yeah.
got into crypto as well, right at the top. But just regarding just Cosmos being the Web3 as well, similar to Polkadot in a way. Just for their validation process, how do you see the validating on Cosmos compared to Polkadot? I mean, we validate on Polkadot on some parachains, and just want to hear your take on what's going on with Cosmos and the validation process over there.
Yeah, so I'm not 100% sure exactly on how it works for Polkadot. Besides, I think the main difference, which everyone knows about, right, between Polkadot and Cosmos is that in Polkadot you are forced to have shared security. So you share your block production, or at least the voting power block production, with the relay chain. I think it's called the relay chain.
Mhm.
While on Cosmos, this is separate for every single blockchain. So every single blockchain within the Cosmos ecosystem is not dependent on the Cosmos hub. They have their own validator sets and their own parameters, and therefore also they're a bit more separate. So they can build a blockchain without ever interacting with any of the other ones, while Polkadot you're forced to work together. And there are, I
Hmm.
guess, positives and negatives to the system, of course, which is why these two separate ecosystems exist, because their vision is slightly different.
Yeah.
But for specifically for Cosmos chains, it's a delegated proof of stake mechanism. So every chain has an X amount of validators that can be active, as they call it. So I think the Cosmos Hub has 130 active validators. Secret has 80 active validators.
Hmm.
There's some chains in between, and you have to run a node, basically activate yourself as a validator, and then you can only join this active validator set. So one of these 80 people, for example, if you have more delegations than the 81st person.
Gotcha.
Yeah.
Yeah.
Less than what
And this is how
simulators.
you slowly climb the ranks. And this staking or these delegations, they come from users. So you can join the set with only having one secret, for example, or one atom. You just need to have some friends, or
Hmm.
get started and have a big enough audience that people are willing to delegate to you. And as soon as you have more secret than the person lower than you, you join the active set. And I think currently for secret, it requires like 120K secret. So it's like $120,000 to join the active set. So yeah, that's it.
Yeah, it's really cool. Actually, um, I had a question about secrets tokens because I know that there's two different types. Maybe you can just kind of give us a rundown of how the both of them work. It might be a good segue.
Yeah, I guess there's in Cosmos, you just like on Ethereum, you separate out coins and tokens, where coins are the native component of the chain. So, for example, on Ethereum, you would have ETH, and on Secret you have SCRT, and on Atom on Cosmos Hub you have Atom and stuff like that. And then there are tokens, and Secret is designed in such a way that the coin is public. So you have Secret, which is the secret coin. It's public, so you have if you just send Secret to someone, it's a public interaction. But also, if you pay with Secret, if you use it as gas, then that is noded on the chain. This has some specific use cases, but it's not specifically important. Anyway, there's also a token version of Secret, the coin, which is called S Secret, so Secret. And this is then a privacy preserving token, because all tokens on Secret Network are privacy preserving by default. So you can have as ETH, as Atom, as Secret, but also, for example, protocols which are built on the Secret blockchain, which have their own token, for example, Shade or Alter or Sienna. Their tokens are automatically privacy preserved.
Oh, that's very
Does that
interesting.
does that make sense? Or
I think that's sticking, yeah. So that's really cool. So let's just get an example for Secret. Are they kind of also like the hub of just privacy for lots of other crypto companies or maybe entrepreneurs to come to Secret and to get the tools that they need to build privacy platforms in a way?
Yeah, that really is the vision, and it takes quite a while to gain like an audience and gain developers to do this. But I think recently a very good example joined the network. I'm really happy they're here. They're called Serenity Shield, and they're basically a blockchain agnostic application. But what they do is they build a strong box, is what they call it, and it's basically a safe for any user to store some data. Uh, and this data specifically, they intended to use this for like private keys and stuff like that. And then this Strongbox has an access mechanism where you can set amount of years or an amount of months or whatever that it's unlocked basically. But this unlocking can also happen by having other relatives share your keys. So what they do is they make basically a contract on Secret Network, and the access to this contract is then divided over multiple different private keys, multiple different people. So you yourself have a key. The contract has a key of your new storage facility, but you can also give one to your relative. So if something ever ought to happen to you, you only need 2 out of the 3 signatures to open the Strongbox and get your information. So a relative can open the Strongbox for you and get your data. So in this way, a secret contract is literally used as a sort of they don't really have a blockchain. They just built an application. You can store your Solana keys in there. You can store your Ethereum keys. Like, it doesn't really matter. From any other blockchain, you can pay with that respective currency and have this application launch on Secret. But it's not specifically a dApp only meant for the Cosmos ecosystem. So this is the kind of privacy as a service Secret Network aims to deliver to projects, basically.
Yeah, that's really cool. I did see that you guys had a podcast with Serenity. It was called what was it called again? That blockchain company is something Shields, Serenity Shield,
Serenity Shield.
Serenity Shield. That's
Yeah,
right.
yeah.
That's really interesting. I remember we had a chat with this company called Mangata, and they really spoke about how wallets need to be a huge thing to change. Wallets need to get better, and that sounds like having certain keys to store in a storage on in the cloud is getting into the area of where you could have your wallet just really safe and secure and not have to deal with losing your funds or something like that. So that sounds really cool.
Yeah, and the problem where you don't only save the keys for yourself, like I know where my stuff is, but someone else, if something ever happens to me, someone else also needs to know where it is, and then that's a problem. Not really solved at the moment. So it's cool that they're trying to do this.
Yeah.
And on the wallet front, I'm actually very excited about a use case which Secret is talking about a lot recently, because it came from Guy Ziskind, which is the founder of Secret Labs, which is a core development organization on Secret. And he speaks a lot about MPC wallets. I don't know if you're familiar with Fireblocks, for example, but these are like institutional grade solutions where you're never a single signer, but there is another entity or another party which signs every transaction with you. And for Fireblocks, for example, this is a centralized company, so they say, hey, we are your second signer. But what they do is they give all these access control mechanisms. So, for example, we make sure that no one can, like, if you ever lose your private key, we can set limits, for example, that you can only send an X amount of dollars every day or that you can never use this specific protocol because you initially stated that you didn't want to, or something like that, which is not possible if you only have your single private key. But decentralized companies are a bit of a problem, right? Because if they run away, like if they lose, or if they stop signing, basically, then you also lose access to your funds, or at least you lose access to the access control mechanism. So Guy Ziskind is now trying to find a team which basically wants to make these MPC wallets unsecret, because the problem with a centralized server completely goes away if you use a secret contract instead to host your other private key, like your second signer. So you can put all these secondary keys and these other signers of all these individual wallets just on the secret network, and they will automatically sign. And they are a blockchain, so they can never, what you say to the contract what he needs to do initially, that's what will always be done, because the code can't be changed. So it's a more secure and therefore also a private way to have like these multi-party or multi-sig wallets on chain.
Yeah, that sounds like a very like novel idea. But at the same time, exactly like you said, it sounds like that's the next evolution of where things are going. Because even when you think about in the Web 2 space, like there's just nothing similar to that that gives people that peace of mind. And even if you lose your, access to your bank account, that process to get that access back is ridiculous. And you
Yes.
know, it's even more felt in the Web 3 space because there isn't that centralized location you can go to request it, right? So I think that's awesome. I'd
Yeah,
love to hear more
it's
about
like a
that.
two-factor authentication for your wallet, basically.
Exactly.
Um,
Yeah.
and also access control. So you have like these. I think on your credit card or whatever, you probably have spending limits, right?
Hmm.
And there's not really a way you can currently do that on chain, but these MPC wallets allow for that, because your co-signer, like your partner, which is the blockchain,
Hmm.
um, you can give him any parameter you want. You can say, okay, I will initiate this contract, and I want to make sure that on this wallet I can never spend more than X, or I lock these funds for that amount of time. You can completely design it the way you want it to be. So that's cool, in my
Yeah.
opinion, at least.
No, I agree with you. Absolutely. It's cutting edge stuff. Um, but also, speaking of contracts, can you kind of walk us through how secret contracts work? Because obviously, there's that extra layer with, the privacy preservation, and I think that would be kind of interesting to get a high level on.
Yeah, so I can go very into the deep end if you want. I don't know how if you want to go into the encryption technologies used and whatever, or just a high level overview.
Well, as much as I would love to take up your whole day and talk about it, I think maybe high level would be probably the best to keep it short.
Yeah, it's okay. Um, it works very similar to any other Cosmos chain. So let's put that out there. It's not like there are significant barriers or something. So a contract can be initiated by someone, right? So an entity or someone makes a secret or a Cosmos or an Ethereum contract on the chain. They say, okay, hey, this is a smart contract. I designed it to do this and this, and anyone from now on can interact with it. And as soon as this contract is on chain, all the data that ever goes through this contract is stored specifically in this contract on the chain. That is how secret works. So the part of the secret network state that is related to this specific smart contract is stored inside this smart contract. And then what happens if a user wants to, for example, I don't know, put some funds in a pool or something, or in a liquidity pool. They say, hey, smart contract, I want to put an X amount of this and X amount of that in this pool. So here is my information. And what they do is they encrypt their information on the user side. They send it to this contract, and then the contract, via a novel mechanism, you can read it in the documentation or we can go over it later, also has the ability to decrypt this information, because the user and the contract share the secret. And only the user and the contract share this, and nobody else can know the secret. So any data that you send to the contract can also be decrypted by the contract, The contract then does what it's supposed to do, right? It says it's a liquidity pool contract, so it puts this in a pool, and it will give you a share of the swap fees if you ever decide to return it. And then the contract just commits this to the chain. So they say, hey, this user did this and this, and now they have X and Y Z part of this pool. That's then put onto the chain. Like all the validators say, yeah, this is correct, and then they put this onto the chain. But what they put on chain is also the encrypted information. So you send it to the contract decrypts it, processes the transaction, then encrypts it again, and then puts it on the chain. And as soon as you want to access your data one day, you basically like nobody can basically access your data, right? If they query the chain, they only see encrypted information. So there's no way they know what is happening. So what you do is you say, hey, contract, remember me, I am this person. And there are like two mechanisms how you can do this. They're called viewing keys and permits. And only the person who initiated the initial transaction can make them. And these basically tell the contract that you are the person who you said you are, and then you gain access to specifically your data. And if you ever want to share with someone else that you did something, like I own this NFT, then you can share this viewing key or this permit with this other person, and they will also get access to this data and be able to verify that it's on chain. Because there is a big difference between just sending someone some data and saying, hey, this is true, and actually providing someone the key to only your data, not to your transaction, but only to the data of this transaction, and say, hey, see, you can see the same thing as me, it's on the chain there. And that's basically what this whole auditable private smart contracts is about.
Awesome. I guess another question that I have for that, because I know that you mentioned that that's a really good way to prevent front running and any kind of like in the middle issues that could arise. But does the encryption and then the decryption process, does that cause any latency when these smart contracts are getting executed? Because it seems like it's a necessary extra set of steps, but does that mean that the user would experience a slowdown in their transactions?
So there's no latency. Secret has a 6-second block time, and blocks within the Tendermint consensus have instant finality.
Wow.
So on any Cosmos chain, the block time is the amount of time that it will take for your transaction to confirm. So to basically correct immediately. So if I submit a transaction like what I just said, supply something to the pool, it will take 6 seconds to confirm. That's the only caveat, is that my transaction is of course immediately included if I set like the correct amount of fee and whatever. If I didn't, then it might not be included. But for now, if I give enough fees and my validators like me, which is the case for 99.9% of the cases, then it's immediately included. So there's not really a latency, but it of course does give some computational overhead.
Yes.
So a secret block can have a little bit less transactions than a block on Juno, for example, because it requires more processing. So you need to make sure that the hardware that the validators are running is strong enough to process the entire block if it was full. So there's a little bit less room in a block on Secret Network than there is on another Cosmos chain, because the overhead of the encryption is around like 30 to 40%. That's at least the estimation. It's a little bit less efficient.
But
yeah, go ahead.
No, I was just going to say less efficient, it sounds like, but still comparable or faster block times than, I think what we're even used to seeing in some other networks as well. So that's quite impressive.
Yeah, I mean, Cosmos has very fast block times, and this is what the original vision was, right? It needs instant finality, because otherwise interoperability is very hard. Like on Ethereum, it's harder to, for example, connect your blockchain to Ethereum, because you need to wait 20 or 30 minutes to have probabilistic confirmation that the transaction will revert. And on Cosmos, this is not a problem, because if I say this is correct, then after 6 seconds, everyone agrees that the state will never change. So it's more something we inherit, sort of the the design of the Cosmos SDK. But yes,
Oh,
I think it's nice that you immediately know if your transaction went through.
no, that's for sure.
Yeah,
Nobody wants to
maybe.
wait.
Yeah, maybe it's just something we're not used to on
Maybe that's
the
what it is.
Polkadot side of things.
So I was
I don't
hoping
know
to just. Oh, go ahead.
what is the maybe quickly what is the confirmation time on Polkadot? I'm actually not sure.
Well, some substrate projects have some blocks are around 12 seconds.
Yeah, 11 to 12, I think,
Yeah.
off the top of my head, but don't quote me.
Yeah, I guess it's the infinite scale of, do I want longer block times and bigger blocks, or smaller block times and smaller blocks? Because, for example, Athmos, which is a project in the Cosmos ecosystem, they decided to have even smaller blocks,
Hmm.
but provide 2.5 seconds block time.
Okay.
So your transaction confirms really fast, but less transactions fit in a block. So the amount of transactions per second doesn't change. They just say we have more increments of smaller confirmations, basically.
Okay. I was hoping to bring this back to validation. We made our whole podcast about talking about nodes, just because I wanted to get your take on what you think about, especially the latest stuff in the news about the cloud service saying they're going to shut down, and everybody was talking about how they're saying all the altcoins are centralized because they're being controlled by mostly AWS or some other large centralized cloud servers. I was just going to get your take on what you think about people saying that about all the altcoins beside obviously Bitcoin. um, what do you think about people saying that they're all centralized due to AWS having the most cloud service for validating on Ethereum and Polkadot, and I'm sure even probably Cosmos has a lot of mostly cloud service running validation, correct?
Yeah, there's a lot of chains have this problem as well. I think in general, something a lot of people are missing is that there is a big difference between block production and validation. I think this is even something that people miss about Bitcoin, where um, miners are just producing blocks, right?
Mhm.
So even though their decentralization is somewhat important, in the end, every single validator, so every single CPU in the Bitcoin network is a vote. So as long as the validators, or like the people running full nodes, are decentralized, then there's not a big problem, because they will always determine the correct thing. Um, and this is a little bit more different when you start to get into the proof of stake networks and delegated proof of stake networks, because I see a huge problem in Ethereum, for example, where yes, there are thousands of nodes, but all of these nodes are by the same company. It's basically one huge Sybil attack, right? Where I think it's Coinbase and Lido Finance and Binance or something. They hold like 45% of the
Wow.
validator nodes on Ethereum. Um,
Hmm.
these are these are scary indications, and in these networks, these validators are literally in control of these people. So if the validator decides to do something, then that happens for an entire network. And in Cosmos, this is a little bit different, where every validator has voting power, and their voting power is dependent is important for block production. But delegators can switch to any other validator at a single moment in time.
Yeah.
So if something significantly ought to happen, where a validator is misjudging something or doing something wrong or double siding, then delegators can immediately switch away. And this is not feasible when you're locked in a single validator node on an actual proof of stake network. So in that sense, delegated proof of stake has some pros, but it also has some negative connotations to it, because it's like a zero sum game, right? If
Mhm.
I'm a validator, I want to have as big of a voting power as possible, while the network wants you to have as little voting power as possible to give a lot of decentralization. But anyway, getting back to your question about like server providers, I think on Cosmos, like 10 or 15% of the validators host their validator nodes in like their own home or in their own office.
That's
So
what I was going to start touching upon there is that,
yeah,
a lot of people are saying, uh, well, mostly on Twitter and stuff like that. I guess it's just FUD really at the end of the day, but they're
Well,
just saying, altcoins are centralized. Jeff Bezos is going to pull the plug. And, like you keep seeing those messages being tossed around. But at the end of the day, as the general public becomes more aware of validation and getting involved, I think having your own data centers at home is the future of uh the altcoins becoming decentralized. I think we just need to
yeah,
have more validators. We need more of them from home, and I think the general public needs to see that they can make some passive income by being involved and checking these projects out.
it's a good thought exercise. Like what? So this actually happened in Cosmos, so we can look at this. There was this cloud platform, and I'm blanking on the name currently, so forgive me for that. But um, it was used widely in chains like Osmosis and Juno. It wasn't used for Secret because Secret requires a specific CPU, and it was not carried by this cloud provider. They're called Hetzner, by the way. Hetzner.
yep, that's the
Um,
That's
ones.
the one.
and they basically gave a quick notification to all their service providers saying that from this moment onwards, validating or doing anything related to cryptocurrencies is no longer part of our terms of service.
Hmm.
Um, and what then does actually happen? It's, let's say Hetzner really decided to just cut off the power immediately and just stop all the nodes. Then the only thing that would potentially happen is that chains would halt. So what would happen is more than 33% of the voting power might go down, and in Binance fault tolerance consensus mechanisms like Tendermint, that would cause the chain to halt. But what can now happen is if people just redelegate their stake to nodes that are actually still running, then these validators who are not running in this Hetzner center will just gain more stake, and the ones that were running in the Hetzner center will just fall out of the set, and the chain would slowly start going. So the delegators here have the ultimate power, right? Even if all the data centers would go down, then the chain just stops, and then there's this moment in time where all the delegators basically have to decide, okay, maybe we should run our own node and start the chain back up or something. But it's not detrimental, like it doesn't finish the network or something, simply because it's delegated proof of stake. So yeah, I think that it's an interesting, in some way, yes, block production is a little bit centralized, but it's the single holders of all these tokens, these delegators, that ultimately decide the direction of the blockchain. So it's not like some Jeff Bezos, for example, could alter the direction of the chain. Like that's not a feasible thing. It's just if he shuts down the power, then all these nodes should stop, and you have to make sure that enough new nodes spin up so that the chain can get going again.
Yeah.
Hmm.
Put an end to
Um,
the FUD right here.
Yeah.
Nice.
and it's an interesting conversation, and I think we can all agree that uh, some of these Cosmos networks are definitely less decentralized than Bitcoin, for example.
Mhm.
But I think this is more on the token level, like which people are holding what, than that it's important who is producing the blocks.
Yeah, I think that's a really good distinction to make, because we could probably talk all day about how consumer hardware is kind of bleeding itself closer to enterprise kind of hardware, so people can get access to these machines that you 5 or 6 years ago could only get if you worked at Amazon in a data center. So you can it's just a matter of infrastructure, I think, at that point to do anything further.
Yeah,
But
I think the reality why people use a data center is because it's easy, not because they can't get the hardware. Because the hardware is not
yeah.
significantly a problem. Like you can, if you have a system with like 128 gigabytes of RAM and a good CPU, you can run, I think, 4 or 5 Cosmos chains on that. So you can run like uh, Juno and 4 smaller ones on the same machine. So if you have 2 machines, then you have a backup as well. So it's not that expensive. It's more that it's a lot easier to just ask your data center, hey, I want to launch a new chain. Can you quickly put some extra RAM or an extra core in my machine?
Yeah. Hey, I'm just gonna run this script, but we're gonna need to double the RAM. Exactly. Yeah. I'll just pay that extra monthly fee.
Yeah, it's
Yeah.
easy, right?
Absolutely, yeah. Definitely economical, but we are coming kind of close to like the end time that we had you for. So um, maybe we can just talk a little bit about how people can get involved, how you can become a secret agent like yourself. Maybe that's a
Yeah.
cool
So
end here.
um, of course. Yeah, so I'm very big into the entire Cosmos. I like the ecosystem. There's a lot of interesting projects, in my opinion. It's interesting tech, but please make sure to check out Polkadot and all the other ecosystems as well. There are a lot. But if you are specifically interested in privacy preserving smart contracts and secret network, then feel free to check out our website. It's scrt.network. And on this website, there's also a page called scrt.network/agents. And if you go there, you can become a secret agent. You can simply click the button and you can enroll. And a lot of community members are not secret agents. A lot of other members are. But what secret agency is we simply make it more enjoyable for everyone to learn about decentralized technology and about privacy. So we host several missions and quest lines where people can engage, get some rewards, and learn about how to interact on social media, for example, or learn about blockchain technology. We have a working group which is specified to contact universities to see if we can host like hackathons and stuff there. So it's just an interesting small community where you can get to grips with working in Web3 and maybe find your own place in Web3. It's really a funnel for everyone to learn and make sure maybe they end up in a nice role somewhere part time or full time over time in the Cosmos ecosystem. So if you're interested, feel free to join, and otherwise you know where to find us.
Awesome. Yeah, I think I know that I'm definitely going to be taking a look at it because it sounds just like you said, very interesting, very forward thinking, which is something that we love showcasing just as much as I'm sure you do on your podcast that you go to as well. So thank you so much for joining us. We honestly, we'd love to talk to you again because there's so much going on. There's so much innovation happening. And we just wanted to thank you again for taking the time to join us.
Yeah, no problem. I'm always happy to join some of these things. It's why I have my own podcast as well, to just talk to people and get their opinions on things. The IBC ecosystem is huge, and there's a lot to learn. There's a lot of things happening. Uh, Interoperable smart contracts already get me super excited. So if you ever want to talk about IBC or about how this works in Cosmos, then I'm always on for a chat. So just let me know.
Awesome. All right. We'll make sure that we put all the links to all the stuff we've been talking about in our description for this post as well. So thanks so much, Erdemann.
Yeah, thank you.